It's upsetting to see, but as time goes by, more and more of the plastics in our precious old machines are degrading and becoming brittle. For this video, I will focus on the Commodore 64 Breadbin, mostly because I have loads of broken cases here to demonstrate something I recently discovered which could be the answer to some of our prayers. This affects all of these old machines, either through the ravages of age or the tender ministrations of our postal services. All of these cases have suffered. So far, externally, they're holding together reasonably well. Inside is a different story. The biggest problem I've come across when making repairs to these machines are these broken screw posts, especially these three across the front of the top of the case. These are the posts that hold the two halves of the case together, and it's not unusual to see all of these snapped off or missing altogether. Up until this point, if I see all three screw posts are broken, the case is written off as I've no way to repair these reliably. Now, while I love a good resurrection project, we have to be realistic. Sometimes a case has spent 40 years being a chew toy for a dog, or has been shattered into so many pieces that even my UV resin can't save it. When you hit that point of no return, that's where today's sponsor, PCBWay, comes in. Most of you know them for their high quality PCBs, but their 3D printing service is a hidden gem for us retro enthusiasts. If your C64 case is beyond saving, or if you're looking to build your own ultimate C64, you can actually head over to their site and upload the STL files for an entirely new case. And I'm not just talking about hobbyist grade FDM prints. They offer industrial resin SLA for a finish so smooth it looks like it came out of an injection mould, or maybe nylon SLS if you want a case that is virtually indestructible, or even tough resins which are perfect if you want to recreate those internal clips we've been talking about with professional grade precision. The best part is their instant quote system. You just drag and drop your files, pick your materials, be it PETG, resin, or even CNC machined aluminium if you're feeling fancy, and they'll handle the rest. It's a brilliant way to keep these machines alive when the original plastics have finally given up the ghost. So if your current project is looking more like a jigsaw puzzle than a computer, check out the link in the description below and see what PCBWay can manufacture for you. Now, let's get back to trying to save this Breadbin with some light activated magic. Another area of interest, and one I've seen many others cover before, are the case clips across the backside. There are two different styles of these. Some have these chunky clips which rarely break and work really well, but most have these thin clips which were never designed to last more than a few uses, let alone 40 years of opening and closing. I wonder which ones cost Commodore more to make. Again, it's not unusual to see all of these thin clips broken. In fact, in all four of these example cases, there is exactly one clip that survived. In this video, I will share my new method for repairing both the case clips and the screw posts, and doing it in a way that I feel is stronger than the original plastics were right back when these machines were rolling out of the Commodore factories. It's not a new wonder product or some secret sauce concocted from kitchen ingredients, and to save you time, I'll give it away right now, as it really isn't that big of a mystery. Then you can rush off and experiment for yourself. But do me a solid though and leave the video running, maybe even subscribe. This is UV resin, often used in arts and crafts to make all kinds of shiny things. But before we get into this and what it can do, I want to wind back to how this all started for me. As many of you who watch my content know, I fix a lot of Commodore 64s. A lot. And one thing I really don't enjoy is repairing the plastics. I also don't like cleaning keyboards. So if anyone has a wonder product for that, please let me know in the comments. Anyway, I don't enjoy repairing case clips or screw posts for a few different reasons. One, it's messy, and working with two-part epoxy, which up until now has been my go-to glue, is unpleasant. The smell gives me a headache and it makes a sticky mess. Two, it takes ages. This 5-minute Gorilla two-part epoxy takes 24 hours to cure. Not 5 minutes. That's just the amount of time you have to use it before it goes off. 24 hours is a long time, and I'm not a patient man. 3, even if you get it right, the strength of this glue is not guaranteed to be high enough to deal with the pressure you can put on a case clip if you get it slightly wrong when fitting a case back together. Sometimes they just pop right back off. And 4, up until now, I couldn't actually repair screw posts, not the long ones that hold the case together. These are just too long and thin. The original plastic is super brittle, and the pressure of a screw being driven into these with any kind of force is enough to shatter them. Two-part epoxy is good stuff, but it has a lot of downsides. So let's talk about this other resin-based glue. Like all the best ideas, this one is a group effort and other people are involved. In this case, it's one of our retro hardware Discord friends, Gedgehead. This clever individual shared with us his toast rack project in which he took one of these, a ZX Spectrum Plus 2, a good machine and the first of the Amstrad created Spectrums, and turned it into one of these, a 128K toast rack, a much more desirable incarnation of the ZX Spectrum line of machines. Inside, these are pretty much identical electronically, with the obvious difference being the tape deck on the Plus 2 and the toast rack on the toast rack. Gedgehead, with surgical precision and a big saw, chopped off the tape deck from the Plus 2 and reattached the end of the case. To fix the two parts together, he used cunning and his knowledge of dental acrylic. This stuff. Now, I won't be using this questionable bag of white powder in this video. I'm sure this is amazing and would probably work just as well as what I will show you next. But I want to share something that is cheap and readily available and also maybe safe-ish to work with. I'll save this for another video though. Gedgehead slipped me this bag when he was exhibiting his custom Spectrums at the Retro Computer Festival in Cambridge recently. We got to talking about the different applications and he mentioned that he'd rebuilt a C64 screw post using this product with a latex mould. I was intrigued. After that event, I managed to bring home a horrible lurgy which floored me for a few weeks and made me forget about most of this until I randomly came across a listing for UV-curable resin on Amazon, which set my mind racing. I searched around for the cheapest listing I could find and without much hope of success, I ordered some. Before I continue with the interesting bits, I should just make everyone aware of a few important safety points regarding using resins and UV lights. If you use anything like this where a reaction is taking place in a liquid, there's a good chance that a byproduct of this will be some off-gassing. I don't know what this stuff is made from, it has no ingredients listed on the label. There is a warning sign here at the bottom, but the accompanying text is so small the resolution of the printer they used to make the labels couldn't reproduce the text. I would also avoid getting this on your bare skin. It's likely an irritant. Another point to make is that UV light, especially the UVA light from this lamp here, is very unhealthy for your eyes. It's probably not amazingly healthy for your skin, but eyes are the things you need to protect when using one of these. A set of suitable protective eyewear is advisable. That is the end of the safety warning. I honestly didn't expect this to be very useful and set about testing it on some broken case clips. The ones I use are printed with translucent PETG. This was just because that was the colour, or lack of it, that happened to be loaded onto my 3D printer. A happy accident, as you will see later. So let's fix a C64 clip first, going through it step by step. First things first is cleanup. I like to remove the stubs of the old clips as they don't serve any useful purpose now and can actually hold the case apart in some cases. A pair of flush cutters and then a quick file to neaten the edge. Next, this section here can have raised bumps. No idea why, and they're not always there, but even if they're already smooth, I like to file away at this surface to roughen it up. Once the bumps are removed, I scratch away with the end of a file to create a key for the glue. Then a clean with isopropanol and a blast of compressed air to clear out the area. A generous dollop of glue can go in here. It's not too important if you use too much, but you want to make sure you have enough as it will be tricky to add more later. I also like to add a dollop to the fins of the new clip. One thing I've started doing since filming this video is using blue tack as a dam to prevent this resin running out of the bottom. I should briefly talk about this specific clip I'm using here. This isn't the regular one that you may have seen on other channels or for sale in various places. I never really got on well with the long type of clip, and when I stumbled across this variation by someone called Ken Mills on Printables, I knew I had to give it a try. It's made for the VIC-20, but as we know, Commodore recycled everything, and the cases are, for the most part, the same thing. I should note at this point, before many keyboards are hammered by angry commenters, that there are many different versions of the Breadbin case, and in the past I've had trouble making the long clips fit in some of them. But suffice it to say that this clip by Ken Mills will work with many types of Breadbin C64. That should please the lawyers. I imported the file into Tinkercad and modified it slightly. I found this top part where all the strength is needed would be better with a little more bonk. Other than this is the same as the original designer made. One more modification will be to add some of the UV resin to the back of the clip, and here we will see this wonder stuff in action for the first time. I've found that the weak point of these clips is right here. I've had one snap right off at this point. So to prevent that, I want to put a blob of resin across the backside where it will give this joint extra strength. Now, for your entertainment, I will attempt to snap one of these clips, and we can see, even with my feeble strength, it didn't really put up much of a fight. So let's fix that. This resin is reasonably viscous in its consistency, not too runny and thick enough to work with. A blob on the back of a fresh clip covering the weak spot, and then the magic. A very strong UVA lamp will cure this resin in a matter of seconds, 30 seconds in fact, and with that cured, can I snap this clip? Look at his little face going all red. So the answer looks like no. The resin has defeated my puny strength and feeble fingers. The good thing about this clip design compared to the other long clip is this one has these ridges where the glue can flow into. This creates a much greater surface area and makes a much stronger bond. If it's going to fail, it won't be the 3D printed side. With the glue on both sides, I simply place the clip into the slot and line up this edge here along the back of the case. Unlike with two-part epoxy, I don't need to clamp this in place and leave it for 24 hours. No, this time all I need to do, being careful not to knock the part out of alignment, is blast it with UV light from my amazing death ray lamp. Thank you again, Phil. If you want one of these lamps, there will be a link in the description. They are amazing. But get yourself some protective glasses. They not only will save your sight, they are also incredibly stylish. Link in the description. Because the clip is printed in translucent PETG, the UV light is able to penetrate through to the resin, and just a few seconds with this lamp is enough to start the curing and hold it in place. Another 30 seconds later and this is fully cured. It's pretty strong at this stage and I would need a lot of force to break it off, but just to make sure I like to run another bead of resin along either side of the clip and cure that to give it extra strength. So a job that used to be messy, tricky and time-consuming now takes me less than 5 minutes to do. I timed it, and is stronger than the previous methods. I'm pretty happy with that. I honestly can't imagine how these can be improved. They fit, they're super strong, and installing them is incredibly easy. But what about the screw posts? Well, this is a slightly different kettle of worms. The thing that makes these really tricky to repair, and the reason I haven't even attempted this up until now, is gluing the plastics on these thin posts is almost guaranteed to be a waste of time. Let's say one of the posts breaks off at this point here, which is quite common, and you usually have the broken part still screwed to the other side of the case. And let's say you take some super glue, which is reasonable given it has super in its name, or even a plastic glue, and you glue that post back into its rightful place. Well, the problem is you still have the original weakened plastic. The plastic that was so weak it just gave up after having a screw driven into it, or taken out of it. And even if you get a perfect joint, the likelihood is this will soon break again in a different place. And that's pretty much game over for that post. Well, I did some experimenting and I came up with a solution I'm happy to report is not only stronger than the plastic posts as they are now, but probably stronger than the original posts when they were made back in the day. They're not perfect and can still break, but they should get you out of a tight spot if you have a case with a full set of broken posts. My first attempt at this was to wrap the stub of the remaining post in clear repair tape. This is thicker than your usual sellotape or scotch tape, creating a tube. Into this I poured some UV-curable resin and I cured it. I won't do this to this post now as I have a better method, but I want to show you there are different ways you can go about this. I could then file down the top to the right height, drill a hole and tap a thread. Just this on my first attempt without doing any other prep was pretty strong all by itself. In that first version I did attempt something a tiny little bit stupid and tried to drill the hole right into the resin without making a pilot hole first. That resulted in the post breaking again. To fix this and give the post more strength, I coated the outside of the new post and the old post with resin and cured that all of the way around. This turned out to be key. With that extra stability I was able to easily drill a hole the right size into the new post and then use one of the old screws to cut a new thread into the resin. Now it's worth noting here that this part is not easy. This stuff cures so hard it's like trying to tap a thread into glass. It will do it, but you need to be super patient and go slow. And if you mistakenly use a larger screw in this, it's so hard it will more than likely crack and break. I'll come back to this threading subject a bit later with a better solution. The tape method seemed to work great and gave good results, but what happens if there isn't enough post to put a piece of tape around to make a mould? Speaking of moulds, these are moulds I made from the 3 different screw posts. I used a mixture of regular silicone like you would use to seal a shower tray or run a bead around your kitchen sink. It needs to be the mould resistant type, which is hilarious given what I'm using it for. Add this in equal amounts to a bunch of corn flour and mix thoroughly. This isn't a very pleasant experience. The smell is awful and very strong. Make sure you're in a well ventilated area. Once you have a consistency approaching Play-Doh, you can jam it around a complete screw post. Before starting I did coat the screw post and surrounding area in silicone grease to aid removal. Wait for a few hours or overnight for this to go off and work it loose. You should have a reasonable mould for a new screw post. It doesn't need to be perfect, just in the right place. This can then be placed over the stump of a broken post, which I cleaned up and cut a slot into the top to aid adhesion. UV resin poured in, make sure it goes right to the bottom as air can easily get trapped. And then shine a UV light into the end. I gave this a few minutes to cook, just to make sure it got all the way through. Then carefully slid the silicone mould off the post. It looks good at this stage. Not perfect, but it doesn't need to be. It just needs to be strong enough to not fall off. Before drilling, I'll run some more resin down the sides of the new post, making sure it reaches the inside of the case. That should make it strong enough for drilling. It's now a good idea to put the 2 halves of the case together and then use a sharp brittle or a long pencil to mark the centre of the hole. Again, this stuff is so hard that even trying to get a small mark into it with a hard pointy tool is super difficult. I then take a tiny drill bit and drill a hole down through the resin into the original hole, trying to keep it as straight as possible. I'll repeat this with progressively larger drill bits until the hole is around the same size as the screw. As I noted before, this resin is much harder than original plastic, so cutting a thread with a screw is very difficult. In my first attempts at this, I did manage to crack the resin when the hole was too tight. So I came up with another solution. Instead of cutting a thread into the resin, I thought it would be better to make a thread with liquid resin and then cure that. Clever, eh? With the hole drilled out to the same size as the screw threads, it can easily be screwed into the hole with minor resistance. Now I need to drizzle some resin down into the hole, not too much or it will be forced out by the screw and make a mess. To stop the screw being stuck in the hole, I coat it with a generous amount of silicone grease, then carefully screw it back into the post. Then another blast of death rays on all sides. The screw is opaque after all, and the new thread should be set, allowing me to unscrew the screw. Now, inside this post is a perfect thread made of super tough resin. I think it's still a good idea to go easy on these. The one downside of this material is its hardness. That makes it less likely to deform and more likely to crack and break. It's a trade-off and just requires some care when screwing the two halves of the case back together. So now I have a repaired post and new case clips, I can put the case back together. It feels super sturdy, much more so than the original clips. As a challenge, I thought I would try replacing this entire post, which is completely missing. The way I made the moulds means they will sit into the corner of the case without needing any post there. This took a few goes to get right. The first attempt, I filled the whole mould with resin, and that just didn't cure all the way through. On the next attempt, I poured small amounts in, cured them, and then made sure they were pressed down. It's really easy to get a bubble, which ruins things. In the end, I made a new post which, whilst a bit ugly, is perfectly sound and functional. It's rock solid. I drilled a hole and made a resin thread the same as the others, and it works perfectly. There are many other uses for this resin I can think of, mostly around the subject of case repair. For example, this piece of plastic on the back of this Breadbin is broken. Gluing this with superglue or the like could be messy, but would probably suffice. But I think there's a better way. Let's assume there's nothing that will press up against this section of the case on the inside. In that instance, I can run a bead of resin across the back of the brake and cure it. First, I want to put some tape across the front surface to prevent any seepage through the crack. Now, a bead on the back working the joint so some glue enters the crack, and a blast of UV. Job done. And this is now probably stronger than the surrounding plastic. I can see this being very useful for many types of repairs, and when I saw this sad disaster unfolding on the Retro Hardware Discord, invitation link in the description, I had to share my secret. This Minitel 1 terminal was bought by Gametin Ben from an eBay seller who thought a plastic carrier bag was the same as bubble wrap. It was posted as a complete device and arrived as a do-it-yourself terminal kit. When I saw this, I just knew that UV resin would be an ideal fit for the job, and messaged Ben and shared with him what I was working on, swearing him to secrecy. He ordered some, and the next message I got from him was, "Wow, this stuff is insane." Not long after, he completely rebuilt the smashed Minitel, and it actually works now. So that's it. I'll be keeping a bottle or 3 of this UV resin handy in my workshop for future repairs. I hope you find this useful, and if you manage to repair something cool, please let me know. Thank you for watching my video. If you would like to see my many repairs involving the bits that go inside these cases, then you can find my repair channel over at More Fun Fixing It. A link will be in the description. If you already enjoy my content and are thinking about ways you can support my channel, you can also find a link to Patreon. Patreon members get early access to all my content, sometimes weeks in advance, as well as regular behind the scenes updates and a super secret Discord channel for Patreon members. And if that is not for you, then maybe just subscribe to one or both of my channels so you have a better chance to see when I post new things. I have a huge list of projects I'm very excited to share with all of you in the new year. And that is now the end of the video. And anyone left watching at this point is a real hero, or possibly asleep. Either way, sweet dreams.